Hi guys, in this video we'll be learning how to create a PCB. So we'll be using a tool which will help us draw a schematic and also design a layout. So this video will be about the basics, how to get started, how to create your first PCB. So before we do that, we have to understand some terminologies. So to do that, we can simply go to this website. So or you can just Google for PCB terminology. So this is how a typical PCB looks like. So there are like a lot of through holes and a lot of white boundaries around the holes, and then there are lines that are going from one side to the other side. Okay, so this is how a PCB looks like. So PCBs are usually made to make a circuit compact, so that it can go into the casing or the housing of the electronic device or an appliance. So this is the reason why PCBs are made. So the other reason why PCBs are made is uh, if you have build your project on a breadboard, you can see there are a lot of wires that will be going from one component to another component, so it's like makes it messy and confusing, and it cannot be a permanent solution. Suppose you put your breadboard upside down, you can see some of the wires coming out and all that, so it cannot be a permanent solution. So PCB is a permanent solution, where they can put all the components together on a single board and then connect them internally in the board itself. So that is the reason why PCBs are made. So the first thing, first term in PCBs would be solder mask. So the green thing, why PCBs are green is because there is something called solder mask. You can consider it as a white paint which insulates the PCB. So the solder mask can be of any color actually, but the main colors that are used for use as a solid mask or the PCBs are available in is green, I guess white, and then black, blue, and yeah, I guess pretty much these colors. So most of the time. So then it is this white things that you see, the markings, the numbers, and all that. That is called a silk screen or the overlay, which will help you identify where to place the component. So basically, a PCB designer is not always the PCB assembly guy. So basically, the PCBs are designed by someone, and then it is assembled either by a computerized assembly or by manually, by someone manually. So the guy so this overlays or the silk screen are pretty much uh, intuitive. They tell you where to place the component. So that is why silk screen is very important. Then you have then you basically have layers. Okay, so this PCB that you see here is a two-layer PCB, so that means there's component on the other side also and the component on this side also, and then the way they connect the component on this side to the other side is like this holes connect them. These holes are on the either side, so they basically go through the board and then connect to the component on the other side. So there can be any number of layers in the PCB. What I have seen is up to 6 layers, but there can be more also. So then there are components. So the type of component. So some component might have pins, so which go through these holes. So such components are called through hole component. Some might not have holes. Some might be just like they might be flat pins which do not require you to put through the PCB. So those components are called SMD components. Okay, so this will be the main components with the type of component that will be coming across. So those are through hole and SMD. Um, so yeah, so this yellow thing or the golden thing that you see, the holes and the copper, those are called pads, and that is where the component sits, and that is where you solder the component to. So those are called pads, and then there is something called trace or the copper track that connects one component to the another. That is called copper track, Then you have the holes. The holes are basically something like, suppose you have a two-layer PCB, it takes the component connection from this side to the component on the other side through a hole like this, which is basically a conducting hole which can take this connection on the other side. So that will be more clear once you get to advanced PCB designing. Okay, so then so it's something like this, yeah, something exactly like this. So uh, so then we have then we yeah, I guess, yeah, that's it, that's pretty much it. So these are the terminologies that you have to know to get started with PCB designing. So this is a pretty um, mm, like helpful website where you can get to learn what are the different things that you have to know about a PCB. Okay, so now for this video we'll be using a software called Driptrace. So Driptrace is available in three ways. So one, you can buy the complete license, or you can download a free trial that will be, I guess, for 30 days, and or you can download a freeware which will uh, be there with you until you have it. But the thing is, it restricts your design to maximum of 300 pins, I guess. I think for most of our projects in school and college, this is pretty much enough. Uh, so when you click on drip trace, it opens up something like this, which says drip trace launcher and a schematic capture, PCB layout, component editor, and pattern editor. So in this video, we'll be going through schematic capture and PCB layout. So these are the main things that should start learning as a beginner. So let's click on schematic capture. So once you click on the schematic capture, it opens up something like this. So it's something like this. So this is it looks something like this. So now you have a window where you see a black screen here, so which is basically our workspace where we'll pull the components and then start connecting them. And then on the left side you can choose the components, and then this will be the schematic symbol, and then this will be the uh, layout footprint. I mean, like how will it look on a PCB? This is how it will look on the PCB, and this is the schematic symbol. So whenever you like go and weave any other component, you can see the schematic symbol remains same because you're still weaving the same component, but the layout is changing. So it shows you different form factors of capacitors that are available. So you can like scroll down this way, and then you can like see the schematic symbol and the footprint of the other components as well. So right now, for this video, for the purpose of this video, we will stick to the components category called general. So you can like switch the category, and you can see the components over here change. I mean, like I mean, like if you go to audio buzzers, it will only contain buzzers. If you go to speaker, it will only contain speakers. So we'll stick to general, which contains things like capacitors, LED, resistors, inductors, and things like that. So so how do we get started is like, so if you suppose we are designing, let's start with a small PCB where we have to rig up LED with a resistor and then connect to a battery. So what I would do is I need an LED and a resistor, so I have to find them and then pull it out into the workspace and then connect them. So I'll do that by uh, going this way down. I'll scroll up till I can find an LED and a resistor. So you know, LED means it is LED, and then RES stands for resistor. So let's not worry about what is RES 400, 500 as of now. I'll explain that in the next video. But as of now, let's take the normal LED. So once you click on the LED, it shows up the schematic symbol and also the footprint. So it gets stuck to your cursor, and then once when you left click once, you can like place it on the workspace, and then right click to come out of the menu. So the basically the LED that was stuck to your cursor is gone, and you can zoom in with your scroll wheel and zoom out with your scroll wheel. So that's how you zoom in and zoom out. So then the same way you can drag and drop the resistor. So I'll place it here, and so I'm done placing the resistor. So I'll right click the mouse once, and so it is gone. So I'm done placing the LED and resistor. So next I would need a battery. So I would go up here and then look for battery. So we have to look for batteries on the left side under components. So we can we can search for it in the general category, but then you won't find a battery in the general category. So you have to look for batteries in under batteries section here. So first we have to change our category to something related to batteries. So we'll look for something which says batteries. So I'll scroll down here. So let's find if there's something called batteries. So it says CON battery holders. So yeah, this is what we should be looking for. CON stands for connector and battery holder. So it will be something which will hold your battery. So we will be using a coin cell battery of 3 volt. So I think this is some the coin cell battery holder looks something like this. So we already have got it in the um, first row itself, but you can like scroll down and see what are the other different types of batteries available. So you can see that the layout footprint is changing, and you can find all different kinds of battery already available here. So let's go ahead and use the first one, and then when you select it, you can see that my cursor is stuck to a battery, and I can like left click and drop it. So that's how you find different components here. You can just scroll a bit. It's self-intuitive. It's like you have the name on top of the category, and then you can, if you are looking for buzzers, you can just click on buzzers and then look for your component type here. So it's very easy to find components and place it in your workspace. So now since I've placed all my components here, so we're done placing the components. So now we have to connect them. So you know this side is the positive side of the LED and this side is the negative side of the LED. And since you all know that resistor doesn't have a polarity, that means it doesn't have a positive or a negative. You can connect it either way. So now, so one important thing that you have to understand here is if there is a square box here on the any on any of the leads of any of the component, that means the component is not connected. It might look silly now, but then when you're designing a big circuit with a lot of components and when you are unable to see it, this square will help you uh, debug whether the connection is made or not. Okay, so just keep in mind that you keep track of these square boxes to verify whether your connections are complete, whether your circuit is complete. Okay, so now let's see how to wire them up. So to wire them up, you have to actually arrange them. I think it's already arranged, so I've placed it appropriately with LED here, resistor here, and battery here. But I guess the positive side of the LED has to go to this side because this is the positive side of the battery. So what I would do is I'll go ahead and rotate either this or this, but I would think this is a good way to rotate. I mean, like, it's a good thing to rotate a battery because this is already in this direction. So let the LED be there. So I'll rotate this battery. So to rotate the battery, I just hover over the component and then left click once, and then I can hit R on my keyboard. So when I hit R, it rotates every 90 degrees. So I'll keep it this way. So now it's easier for me to connect to this, and then this, and then this, and then this. So how do I wire it? So on the top here, I have place wire option. So it's pretty much intuitive. So when you hover over any of the icons, it says what it does. So it says place wire. So you can click left click once, and then you can hover over the lead that you want to connect. So it gets highlighted in red. So left click once, and then you have a wire which is connected to that particular lead. So then you can go ahead and connect to the lead that you want to connect to. So I have to connect it to the positive side of the LED. So I left click here on um, top of the lead of the LED. So what I can do is like I can show you what happens to this box as soon as I connect it. So if you see when I hover over the lead of the battery and left click once, the box disappears. So suppose I hover over this and then start wiring it like this and then go like this, instead of actually going and completing the circuit, like I just did it like this and then I hit done. So now I hit enter. So now I have not made the circuit, but if I see it from the far, mm, like from if you have a bigger circuit and then I have to zoom out to see the entire PCB or entire schematic, I might not be able to see this. So I might just go ahead and start my layout designing without even completing my circuit. So what happens is you can like when you see that there's some issue with the layout, you can like come back to the schematic and find whether you have some incomplete wires. That means like you have to look for these boxes. So that's how you will figure out that there is some error. So this box are really helpful, which will help you whether to verify whether the circuit is complete or not. So this is how I'll wire them. So I can wire this up like this, then I can wire this one like this. So my schematic is ready. So this is my schematic. So I have a LED in series with a resistor and then a battery. So now I have to go ahead and convert this into a PCB. So that is the next step. So before doing that, let's save this file. So you have to go to file and then save as, and I'll save it as my PCB. Okay, so I'll save it on desktop. So once you've done saving, you can just go to file and then you can go to convert to PCB. So when you hit on convert to PCB, it opens up something like this. So as of now, we this is our first PCB, so we don't have any previous layout, so we should just keep it this way and then say okay. So when you click on OK, something like this opens up where you have your schematic is already converted into something like this, which doesn't have schematic symbols anymore. It has the footprints of the components that you used. So this is how it will look like now. So now you have to design your PCB, or basically design the layout, and draw copper traces to connect this components together. Now let's see how to design our layout. So before we do that, like let's just move the components such that they're not placed one on another. So because this is where the battery will sit, and then there is a resistor right under that. So I think we'll have problems soldering the resistor there. So let's move it somewhere like this, and then so to move it you just have to hover over the component and left click and hold, so you'll be able to move it. So this is how you will move it. So I'll move it something like this. I think this should be fine. So now let's start to wire them up. So to wire them up, so you have on top here there's something called route manual. Okay, so route manual will do things for us like it will help us place copper trace. So copper trace is something that we saw already in like in terminologies, which these are the copper traces like which connect from one component to other. So basically like wires on the board. I mean like whatever wires we connect on the breadboard, so copper tray uh, does the job of those wires. So we'll just take click on route manual. So let's start routing them. So the process of connecting the components with the help of copper traces is called routing. So we will just start connecting. So how to connect is like so the schematic is basically converted into this layout, and we are seeing already the footprint. And then along with the footprint, we also see these lines which are blue or purple, whatever color. So these lines are called rat lines, which will already help us how to uh, connect them, like as to like which end goes where. So this helps us like it makes things easier for us. So we just have to hover over the one of the pad or one of the ends of the battery or whatever component you start with. So you just have to hover, it will automatically show you which end should it go to. So by like highlighting that color, I mean like that end in red, so you can see that as soon as I hover over my mouse on top of this, it shows like which other end is connected to this. So that means I have to take these connections to here. So I'll do that by left clicking once, and then then you can see that something stuck, that is basically a copper trace. So I can like go like this and then like this. So I've connected it. So you can see that I've connected it in some angle, so I could have gone straight like this. But usually you shouldn't be doing that straight. If the component is straight along x and y, it is fine to do that. But then when the component is like offset like this, it's better to go in an angle, and the angle you should keep it always an obtuse angle. You should never make an angle say 90 degree or an acute angle, because if you make an angle less than 90 degree or 90 degree angle, it will be like that point in the PCB will have heat dissipation, because at that point the resistance would be very high. So that is why you shouldn't be doing that. So you should always try to make sure that you make a 90 make an obtuse angle while connecting the components. So now I have to connect this side to this side, so it's better I rotate this LED so that this side comes on this side, and then it will be easier for me to connect. So or else I can go this way and then this way and then to this, but instead of that I can like go straight, so that will be like the easy and the shortest path. So what I'll do is to rotate, I'll hit escape first, so I come out of the route manual menu. So and then I'll hover over the LED, left click once, and then hit R. So now it's easier for me to connect this, so I'll just hover over this and then connect to this like this, and then I can do this by this. So now I've done routing it. So now every PCB should have an outline. So we also should make an outline. So to draw outline, we can like go over here and find something called place board outlines on top here. So we can left click once here, and then so to place the board outline, you have to specify the four corners, or if you have many corners, you can specify that also, but it should be a closed figure. So I'll be drawing a rectangle around this, so I'll be doing that by specifying four corners. I'll do that by left clicking once, and then I'll make sure that I drag the mouse away, and then the line is straight, and then left clicking twice, then thrice here, and then while completing the fourth point, instead of hitting left clicking the mouse, I'll hit enter. So when I hit enter, the uh, board outline appears, and it is purple in color. So then what I would do is like I'll just go ahead and place some text. So that will be my silk screen along with the already existing silk screen, like the LED outline, a resistor outline, and the battery outline. So I'll go ahead and say um, mm, B automate. Okay, so once am done placing the text, I can just hit escape or right click. Uh, so then I can like, if my text is like overlapping with something, I can just move it somewhere so that it doesn't overlap. I can place it here, and then I'm done. So after that, it's always a good practice to place copper core. Suppose you are etching this PCB, you can save a lot of time and chemical. So it's good to place copper core. So copper core is something like the software will make sure that there is copper all over the board, so that you can save time and chemical while etching it. And also if you are like milling it, you can like mill some of the areas, not the entire board. So what it does, it basically pours copper all over the board and leaving out our connections intact, so it is our connections are not affected by copper pour. So let's see how that works. So the copper pour, you can find it next to our board outline. So this is copper pour. Copper pour works in a similar way like a board outline works. So you just have to specify four corners, and I would prefer specifying the four corners inside the board. So I'll do that like this, and then hit enter. So once I hit enter, there are a lot of parameters. In this video, we'll not worry about what these parameters are. These parameters are basically like how like how much clearance should it leave from the actual connections and all that, but I would be explaining these parameters in the next video. So for this video, let's keep it to default and then click OK. So you can see the software just poured a layer of copper around, like all over the board, and our connections are not affected by it. Like you can see there is a gap between our wires and then the copper core. So this copper core is connected to the ground terminal, so that when you're touching a PCB that you are basically grounded, and you are not actually damaging the PCB because of any static discharge or some static discharge or anything. So that's why that is another purpose of the copper core. But as of now, we'll stop at this for this video. I hope it was helpful in learning how this tool works and basic terminologies of the PCB. And in the next video, I'll be teaching you some advanced stuff about the Driptrace tool, where you can apply your Driptrace knowledge to make make complex circuits, make complex PCBs for your project. Okay, thank you for this video, guys.